Let's look at astronomical telescope, and a few background knowledge that we need to find out is number one, the power of the lens is 1 over f. So then the setup should be a bit too small. This is an objective lens and this is an eyepiece lens. And the interesting thing is the FO and FE is on the same point. Okay, and this we have a rig WIM, okay, RID and VIM, and then this optical center of the object from one point to the optical center of the lens of the other point, we consider it as L, and this L is equals to FO plus FE, different from just now where it is L bigger than FO plus FE. So the main usage of telescope is to view far objects. So what is low pass? We use telephone, the word tele rhymes with the telescope. We use telephone to call Jennifer Lopez. Okay, so this O stands for objective lens. And why is it weak? The power is weak because the focal length is long. And then we have this E, this eyepiece. And why do we have a powerful lens? Because the focal length is actually really short. The focal length is really short. Okay? So remember this so that you know that the objective lens has longer focal length. You can see it from here, longer focal length of the objective lens. So the light ray comes from distant, really far away. For example, the sunlight or moon. Okay, so U infinity, but 2 rays is enough. Cut through the F, you come up parallel. Cut through the optical center, you just go through it. Intersection between this blue line will give you the final image, and this final image is so happen formed at here, the F, formed at F, FO. Okay, so now the red arrow has become, initially is actually the image, so now it become the object. So let's say it has transformed. So now the green arrow has become U equals to FE. So your V should be infinity. But how does that happen? We need to draw. We need to draw. So what we are going to draw is, before drawing, just want you to look at this one. This one will give you RID. The image here is really inverted and diminished. And here is VIM, as we will discover later. Okay, it's supposed to be VUM, but because it's already inverted. So let me rub off this one to help me to draw the ray diagram carefully. So you have this case, you have the light ray keep on going here. Okay, you keep on going. I assume that I'm gonna draw this again so that it will be more accurate. Okay, so this is not exactly a good drawing, but I'll try my best again. Okay, we can cut off this one also. So what you have is this one, a slightly bigger one. Okay, so seems like the light ray is not able to pass through. So I just draw a general case. So this one will pass through the optical center. It will pass through the optical center, and perhaps this one I'll just sketch it. It's supposed to come from this blue line. Okay, I'll just sketch this longer and try to rub off this one, so it has some kind of longer lens. So this ray that goes through it will be refracted to FE. Okay, FE seems to be here. Okay, if I'm not mistaken, estimated to be here. So your black ray is supposed to go parallel and strike FE. Okay, so this ray 1, this ray 2, this ray 3, this ray 4. Ray 3 and ray 3 goes through the optical center. Actually 1 and 3 through the optical center. Okay, so 4 through FO, and then 2 through FE. Okay, so with this in mind, we can understand how ray diagrams are drawn. We only need 2 lines, and 2 lines is enough for us to make some kind of conclusion. You see, I tried to extrapolate this one, but it seems like I never meet each other anywhere. So perhaps the image is formed at infinity. Image is formed at infinity. Okay, so it might be a case of seeing things in a very distant length away from you. Okay, so in this case, one special thing is here to here optical center is L, and this L is equals to FO plus FE, and the characteristics here is RID and this VIM. The image formed at the left hand side, so very intelligent monkey. Okay, because you upright the inverted is always inverted. So when we talk about magnification, we don't have any complicated formulas. We only have M equals to FO, because low pass, remember low pass. So objective lens is longer, eyepiece lens is shorter. FO over FE. Okay, we always take a longer over a shorter to show that there is some kind of magnification bigger than 1. Okay, so this is the summary of the astronomical telescope. So hopefully you can find out more by reading the reference book, and perhaps you can find more information from the internet.